We're here from BJDJS with Ben Lumsden, Derek Pascoe, Jack Wilson and Scott Rouse. First of all, the robot is designed to move forward till its touch sensor is activated, then turn around, drive forward again until the ultrasonic sensor senses an object, turns around, drives forward until it senses a sound, moves backwards, rotates on point and then stops. Here is the flowchart. First of all, it configures the sensors, moves forward. If the touch sensor is not activated, it will continue to move forward, but if the touch sensor is activated, it will move backwards, then rotate right on point and then move forward again.
This is Ben Lumsden here. Once the robot is moving forward, the sonar sensor is next. If the sonar sensor is not activated, it keeps on moving forward. If it is, it will keep on moving forward for 100 milliseconds. Then it rotates left on point for 615 milliseconds, stops for a bit at 1000 milliseconds, moves forward for 100 milliseconds. Then we move on to the sound sensor. If it's not activated, it will keep on moving forward. If it is activated, it will move backwards for 2000 milliseconds, and then it will stop again and then rotate left on point for 6000 milliseconds, and then we finish.
Yeah, you're here with Jack Wilson now. Moving on from the flowchart onto the pseudocoding. Pseudocoding is easier to understand as it's just got a step-by-step way of going through each of the processes. Yeah, much easier to understand, as you can see. Yeah. And then onto the coding. As you can see, the coding's much harder to understand. Like, there's the touch sensor, a lot harder to understand. The turns on the points, much harder to understand compared to the pseudocoding. As you can see, rotate right, 180 degrees on point. Yeah. A lot harder to understand.
Pascoe here. I'm going to run you through the virtual software that allows us to show our programming in a supposed real world situation. When we programmed our robot, we programmed it for the virtual world. However, there were problems when we took the virtual world programming and put it onto the robot and ran that robot in real life. The turns were far too excessive and it resulted in non-alignment of the robot. So when the robot tried to use the touch sensor or the ultrasonic sensor, it was not lining up the way it should have in the virtual world. With these adjustments being made, as you can see in the following part, where the robot activates the touch sensor for the first time, it only turns a very small distance. This is because the turning times had to be scaled back for real world application. The only part that really carried through was this turn here, this continuous turn. And that's the program done. So thanks for watching from Jack Wilson, Ben Lumsden, Josh Kohler, Scott Rouse and Derek Pascoe.